as you go through your, hey buddy! There was a pictures duel yesterday I read.
Yeah.
Yeah.
Yeah,
We had such a nice streak.
Nice.
Wait, what is that? The picture's
Yes, the pitcher got in a fight. He said, I challenge you to a duel. And they went,
Okay, well, I don't know.
No, it means both, like, nobody can hit, only the pitchers are really doing anything.
Oh. Thanks, Jenna.
Yeah.
She thought that was really funny.
well, it's Jenna, it's a softball player. You gotta give her a little slack.
No, you don't.
It's a joke, Jenna.
Oh.
I'm joking, Jenna.
Oh.
Put your arm down, it really smells.
What's a pass out over here?
What are the triangles? Wait, shut up. What are the triangles called where you go from midpoint to midpoint to midpoint and they get smaller and smaller and smaller?
Pascal's triangle?
Is that what it is?
I think so, maybe. I don't know.
That's what I thought you were talking about, but then isn't that what we were talking about?
Have a good day, Bert.
All right, you two, buddy, go get him.
Oh, I know
who's
what
he
you're
going to
talking
get?
about.
Yeah, we did it for.
You did with Seb,
Yeah.
didn't you?
Yeah.
That was,
Sub did it.
Because that's what I
thought
thought
that
it
was-
was yesterday.
wasn't that Pascal's
I think
triangle?
it is Pascal's shrine.
But
Yeah,
I
it
thought
is.
Pascal triangles is what we did yesterday with the ones.
Isn't that it? I know what you're talking about.
It's probably the same.
Oh, you're the best. See, I figured you would just say, hey, Lincoln, do this for me. You would have, okay.
No,
You
we
would
wouldn't do
have.
that. We're like, shut up, Jenna.
name is Mother.
He's really mean to me.
So when we were doing this stuff yesterday, when we talked about the powers of the exponents, that was really, really easy. It was always the first term, the first value had the highest exponent and it worked its way down. And then the second value started at 0 and worked its way up. And they just kind of crisscrossed each other. The coefficients then, when we're trying to figure out the leading term coefficients, what happened was that if you use Pascal's triangle and you go through the whole thing, the outer edges are always going to be 1s, and the stuff inside there are always made up of the two numbers above it. So as you drew it out, it went down with 1s, then it was a 1, 2, 1, then it was a 1, 3, 3, 1, then it was a 1, 1, then it continued on from there. But that also followed the pattern of the 7 choose 0, 7 choose 1. What's that? Combination. When you did probability last year, remember? Yeah. Yeah. Remember the NCR buttons and stuff like that in your calculator? Give me 1 second. The
It's the color.
Now how will we know what 4 colors the pen can be?
I can make it any color I want.
Can you make it pink?
I could.
I thought you could only use those 4.
So what this does is there's a formula that it was for the NCR, it was n factorial over n minus r factorial. And it was doing that combination. That's when the order mattered when you were picking things. No, I'm sorry, order doesn't matter with the combination, excuse me. So that was the other way that this patterned itself out through. So if you want to remember that the first one is going to be a 7 choose 0, 7 choose 1, 7 choose 2, so on and so on and so on. Think of it as it's following the exponent rule for the second term. The exponent here for the second term is 0, 1, 2, 3, 4, oops, and so on. See how that works? It's a nice way to remember that. So how do you know which part you're going to be at? So that's how those work themselves through. Now the goofy part is going to wind up being when we have binomial, that's just not an x and a y. For example, when we have one that looks like, let's see, where's my next example? If I have 2x minus 3 to the 4th. First of all, we have to worry about the negative sign. Second of all, we have to worry about the fact that there is a coefficient in front of our variable. Since it's a 4th degree polynomial, usually the quickest thing to do is know that we're going to have one. We know we're going to have, let's say if we write this out as an a and a b. Let a equal to 2x, let b equal to y, just so we can see why this happens. Do your exponents first. My first exponent is going to be a to the 4th. The next one will be a cubed b, a squared, b squared, and so on. So let's write that out first. Then I'll show you what happens with the signs and everything else. Everybody okay with that? One goes up, the other one goes, or one goes down, one goes up. Here's what happens with when you have negatives. All they do is alternate. Okay? All they wind up doing is alternating. The first term is always going to be positive, no matter which one we're dealing with. It's just going to do that. They're just going to alternate. Whether it's an odd number or an even number exponent, they just alternate. It just starts with that second term is always going to be the sign of whatever the second part is in here. And it just switches back and forth the whole way through. All right. Now we deal with our coefficients. Think about your coefficients. This one's going to be 4, choose 0. This is 4, choose 1. 4, choose 2. 4, 3, and 4, 4. See how it's following the 4 is always going to be 4 because it's a 4th degree. It's going to be a 7, which was a 7th degree. It's going to be 19th to 19th degree. The second number, where it's 4, choose 0, is always going to be the exponent of the second part of the binomial. So here, the exponent of the b value, if you will, was 0, 1, 2, 3, and 4. That's why that number is that. Does that make sense? It's an easy way to remember it. Now you just got to figure out what that is. There's the button again. So we just use the button on the calculator. So in doing that, this becomes just a to the 4th. The next one is, what's 4 choose 1 is going to be? Is it 4? A, Q, B. The next one is 6. This would be plus 6a squared, b squared. Then it's back to 4 then?
Yeah.
And then just back to 1. Everybody okay with that? Forgetting coefficients? Now look what happens when it does. I'm starting with this right now to show you guys the generic setup of the degrees of the parts. One goes down, the other one goes up. And then I do the coefficients. Now I'm going to go back and what was A? A was 2x. What was B? B was y. Okay. I'm just doing a quick little stuff to help you guys. I didn't want to throw all of the stuff at once. Because I thought that this stepping was pretty straightforward. Now, move this up a bit. We had A was equal to 2x and B was equal to y, right? Oh, sorry, 3. So I have to substitute back in. Everywhere I see an A value, I have to put 2x, and everywhere I see a B, I have to put 3. But remember, it's a to the 4th, so that means it's going to be 2x to the 4th. That whole chunk has to be to the 4th power. That's why I wanted to pull it out for right now to show you guys why the whole thing goes to the 4th power. Okay? It's a very common mistake. You guys will just put the 4 over the exponent, over the variable, and not 4th power of the 2. Okay? I forget what it's called. So now this becomes 4 times 2x to the 3rd times 3. Substituting back. And then we had plus 6, 2x quantity squared, 3 squared. And then it was minus 4, 2x times 3 cubed. And then lastly was plus 3 to the 4th. And all I do is just substitute back in for the a's and b's. And now I simplify. 2 to the 4th is what? 16. So I have 16x to the 4th. Bless you. 2 cubed is how much? 8 times 3? 24 times 4? 96. So it's minus 96x cubed. 2 squared, 3 squared, 4 times 9 times 6.
No clue.
216.
216 x squared. 3 cubed, 27. Double it. Double it twice. Double it again to get, because you have to go times 4 now, so, and then double it one more time. 216 again. And then what's 3 to the 4th? It's 3 squared times 3 squared.
That's pretty strong.
So that's what's happening here. And the idea is that the patterns never change. You just have to be very careful about when you have, you have to be careful with that. That whole first part of the binomial has to be raised to the 4th power. That whole part has to be cubed, and so on and so forth. That's where you got to be cautious. Okay? Let's try to look at that. Let's try this one. X minus 2y to the 5th. I really recommend use that A and B method and then go back and substitute it. Okay? It's like an extra step, but it kind of forces you not to screw up. I hope. So do your exponents. Or do you want, why don't you guys try it? I think you try it. Yeah, sorry. Still, just got a couple more things to show you here. So we do A, and we have A to the 4th, B, A cubed, B squared, A squared, B cubed, A, B to the 4th, and B to the 5th. Signs, first one's positive, next one's negative, plus, minus, minus. And now do our coefficients. 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. So we get 1, A to the 5th, minus, I don't know. Take the chart, see if I can figure it out. So it's 1, 5, and 10. Yeah. 10 again. Oops. 5 and a 1. You all right with that? Yeah. And now we just substitute back in the A and B values. A was X, B was 2Y. So this is X to the 5th minus 5X to the 4th. It's 2Y. And now we get 10X cubed, 2Y squared, 10X squared, 2Y cubed, and X, 2Y to the 4th, minus 2Y to the 5th. Good. Bless you. X squared minus 10x to the 4th y plus 40 x cubed y squared minus 80 x squared y cubed. 16 times 5 is 80. Y to the 5th.
I'm confused.
What's wrong?
How did you do that? Because what I got was, like you don't take
one short.
I just think a different. I don't know.
Did you get the coefficients okay?
Yeah, I did everything right up until like the last step.
Okay. Now, the last bit then is just substituting in what was A and B. A was x, B was 2y.
I did that.
So I have x to the fourth times 2y to the first power, x cubed 2y quantity squared. So 2y quantity squared is 4y squared. So I took the 4 times 10, I got 40.
Okay, but how did?
And then here I get 2 cubed y cubed, so I get 8 times 10, which is negative 8. And then 2 to the fourth is 16, 16 times 5 is 80, and then the negative 32.
Because what I did was I took the I did that all right, but I had like negative 5x to the fourth 10y.
You forgot to write the 2y there, that's why. Because B is 2y.
I think okay.
See what I'm saying?
Okay.
Do you get all the other ones okay?
Sure.
You just forgot to write down a 2, that's all.
No, I did that. I don't know what I did.
What was it?
I did it right, but I did it in the same
He
sentence.
hears everything. I was waiting for him to say something.
I know, you stopped right there.
Well, I know only my team has that.
No, I heard it.
No, I wanted to know because it only catches you.
Oh, sorry, it's supposed to be x to the fifth. I'm sorry, I meant to write 5.
I'm like this video.
I
Say that every
just wrote down the wrong number, that's all. Okay. Alright, now the other part of using this stuff is sometimes you need to find a specific term. So, if you wanted to find the 6th term,
Oh yeah, this is the homework.
yeah, this is actually pretty easy once you see it. Let's find the 6th term in this sequence. Whereas there's a formula to do this. When you're working with this, you're trying to find the 6th term. What you're doing is you're always going to be working with what's called the r plus 1. This equals your nth term. Okay? And then you use the formula for this. And choose r. X to the n minus r, and then y to the r. And this is for, that's for this generic setup. So if you're trying to find the 6th term, you set r plus 1 equal to, what's r? 5. You're always going to find, when you're trying to find the 6th term, your r value is always going to be 1 less. Trying to find the 7th term, you'd be losing an r value of 6, and so on. So you just substitute in. We know that in this case here, move this over. I know that r, in this case, we're looking for the 6th. R is going to equal 5. Our n value is 8. Our x value is a. Our y value is 2b. And then I substitute in. So this is going to be 8, choose 5. A to the 3rd, 8 minus 5. And then it is y to the 5th. Oh, but my y value is 2b to the 5th. And I just hit the button to my calculator again. I figure out what 8 choose 5 is. 8 factorial must be 876 divided by.
Do you want to figure it out or you want me to try?
Yeah, tell me. 56. So this becomes 56 a to the 3rd times 32 b to the 5th. So all I have to do now is do 56 times, I'm sorry, 56 times 32. What do you get for that?
17.
So the 6th term out of that is that.
So that's, oh, that's easy.
That's how you do it. And that's, it's using that generic formula of this stuff here. Okay.
How did I do it? So I figured it out. sometimes like for like the choose ones, there was like 110 on the top and not very.
It just means 10 choose 3.
Oh.
Sometimes they write it like that. It means the same thing. It's just 10 choose 3. It just some of the old ways. I mean, this book is old, so some of the old ways of doing it is just that.
Okay.
That's all. Same deal for if you want to do it the other way. If you just want to find the coefficient, you're just trying to find the coefficient of a term. If I write it out that way, if I have find the coefficient of the a to the 6th, b to the 5th for 3a minus 2b to the 11th. I want to find the can I go too fast on that one? Sorry.
I'm getting rid of the monster. It just looks stupid. Oh.
That's just hard. That was hard.
Your face.
Oh,
You got me good, Mr. Murphy. Real good.
Oh.
We all thought it.
You alright? You alright? Alright. So sometimes you're going to find just the coefficient. So they're telling you you want to find the coefficient of the a to the 6th, b to the 5th part here. Well, if it's going to be that, which term is this going to have to be? Well, first of all, what's your, go back to the original formula. We have n choose r x, I forgot what it was off the top of my head. N minus r, thank you. What's n? Ooh. What's n? 11. In this case, n has to be 11. Now, when I go through the rest of it then, I'm trying to find out what the coefficient is when I have a to the 6th. Now think about that. If it's a to the 6th, this term would start at a to the 11th, right? Then we'd go 10, 9, 8, 7, 6. So wouldn't that be the 1, 2, 3, 4, 5, 6? Was that 7th term?
11.
Oh, I'm ahead of myself. So 1, 2, 3, 4, 5. Wouldn't that be the 6th term? So that means what's my r then? Be 5. R plus 1 has to equal 6, so r is 5. What's my x value in this problem? And what's my y value? 3a and 2b. So I fill in the blanks. 11, choose 5. And then it'll be 3a to the n minus r, which is 6. And then the next one would be negative 2b to the 5th. And I'm looking at just worrying about the coefficients. So in the calculator, I type in 11c5. Then I can multiply that by 3 to the 6th. And then I multiply that by negative 2 to the 5th. Because that's what the coefficients will wind up being, because the variables are a to the 6th, b to the 5th.
Okay, wait, I'm not sure if I did it right, but it's negative.
It's a really big number, isn't it?
Yeah, hold on. 10,000, no, 10,777,536.
And you're right. Did you not, what did you get, Hopworth? What, did you type something in?
Yeah, I think so. I'm looking back at it now.
That's all you're trying to do? Yeah. Okay. That's about as crazy as some of these things can get just by pulling the values out. Okay. Now you should be okay to finish everything that's left.
Okay.
No, finish day 1 and day 2.
Oh, it's due date 2.
Yeah. There's only a couple parts on there.
A lot of work.
I don't, Thursday.
I already did think.
I have 2 tests on Thursday, 2 hours in a row.
Murphy, I have a cord to charge this.
You can have one, borrow one.
You're right.
What if I want?
Hey, that's what I got.
I have US history.